Hello friends, my name is Dafa.
And my name is Max.
We're from Kasaton Bagsa School, and today we'll be presenting our project that adds extra protection to crucial equipment that scientists use during lab experiments. That is,
Lab aprons, with our project called Potential of Pineapple Peel as a heat-resistant and anti-radiation material protection for laboratory apron. Did you know that as of 2023, Indonesia is the #1 producer of the pineapple in the whole world, producing 3 million tons of pineapple. However, it also produces 500,000 tons of pineapple waste each year, and we have found that laboratory aprons lack of material that can protect its user against radiation and heat.
our solution is to reuse the pineapple waste, like the peel, to create a composite that can resist the high heat and radiation, thus reducing and recycling the pineapple waste, as well as making lab coats more safer. Our research objective is to know the potential of pineapple peel, as well as developing a material that have an heat-resistant and anti-radiation properties.
The items prepared are pineapple peels, silicone mold, and epoxy resin.
First of all, we dry the pineapple peels using a dry oven at 100 degrees Celsius for 12 hours or more until most of the water content in the pineapple is lost.
Secondly, we take the dried pineapple peels from the oven into a blender and process it until it becomes a fiber.
After that, we mix the dried pineapple fibers with epoxy resin with 2 parts of dried pineapples and 1 part of epoxy resin, and the result will be a composite that will be experimented and analyzed for its heat resistance and anti-radiation properties.
We have found from the heat resistance experiment, the sample be tested with a hot plate with a thickness of 1.5 centimeters can handle 30 until 50% of the heat at maximum performance. Optimal performance occurred from minutes 1 to 18 with an average sample temperature of 100 Celsius and plate temperature of 161 Celsius.
Optimal performance occurred with an average sample temperature of 122.7 degrees Celsius and plate temperature of 238.5 degrees Celsius. On the other hand, the heat resistance test with a furnace and a sample with the same thickness of 1.5 centimeter can handle 40 to 50% of the heat at maximum performance.
We conducted a radiation resistant test to determine how effectively the material can block radiation. We found a sample with a thickness of 1.5 centimeters can block 35 to 38% of the radiation. Exposure was measured using a Geiger-Müller with a cesium-137 as a radiation source. The emitted radiation was recorded at 2,980.667 CPM with a margin of error of 6.354 CPM.
In conclusion, from our radiation experiment, we found that our pineapple composite can block around 35 to 40% of the radiation as measured using a Geiger-Müller counter. As for the heat experiment, the test using a hot plate and a furnace showed that pineapple peels can withstand temperatures up to 300 Celsius.
The result of this study suggests the following. It is necessary to conduct composite characterization to determine the lignin content in the pineapple used for the composite. 2. Experiment on the radiation effectiveness of the composite sample should be carried out. 3. Temperature measurement should be taken more quickly when opening the oven